Okay, so the last thing, like I said, we're going to cover is position, velocity, and acceleration. Those three things. It is this, a lot of this applies to physics. Now, the physics we cover is just the math behind it, right? Because in physics, part of the things you talk about, three of the things you talk about is position, velocity, and acceleration. Position is where you're at. Where are you at? Okay, that's your position. Where am I at? Sometimes they call it x of t, sometimes they call it s of t. It's the same thing, okay? The derivative of that, the derivative of your position is what's called velocity. Velocity, okay? And they'll call that v of t, but it's also the derivative of position, okay? It's position's derivative. And then the third thing is acceleration. Acceleration. Acceleration is the second derivative of position, the first derivative of velocity. Okay, they're all three of them are related. Okay, so here's a bunch of stuff, important stuff that they're going to ask you. They're going to ask you stuff about, obviously, they're going to ask you stuff about position, velocity, and acceleration, but then they're going to bring in speed. They're going to say speed. How is speed different than velocity? Right? Because they're essentially the same thing. And the answer is right there. Speed is always going to be positive. Speed is always positive. When you drive in a car and you look at the speedometer, right? You look down at the speedometer, it's never a negative number. It's never a negative number. Thanks. That's because it's the absolute value of velocity. Okay. So another word for the number you see in your car as you're driving is velocity. Sometimes you hear velocity instead of speed. The only difference is speed is always positive. Velocity, and then we're going to talk about this. Velocity can have direction. Velocity can have direction. So you can have positive velocity or negative velocity. Okay. Displacement. Displacement, how far you are from where you started. Okay. So if I'm right here right now, and then I walk here, displacement would be how far I am from where I was to where I started. Okay. Distance is different. Distance is total distance you've traveled. So like if I start here and I walk here and I walk back here, what's my displacement? 0. I'm back where I started, right? I'm exactly back where I started. But my distance is everything I walked. Right here. All of that is distance. All of that area covered, all of that length covered is distance. My displacement is 0 though, because I'm at the same spot where I started. Okay. It's like, so another way to think about displacement and distance, if I was driving to East Campus, if I was driving to Central East, displacement is a straight line from my hand to their campus. That's displacement. But we can't do that. Unless we had a plane or a helicopter, we can't do that, right? We have to go down streets, right? So displacement is always different than distance because we have to drive on streets. Okay? That's the difference. Okay? Displacement is how far literally are you? Okay? Like from me to the door. That's displacement. But distance is not that because I have to go around here and then turn and go, right? So displacement is another way to think about it is a straight line distance. Okay? A particle, they're going to ask you, when is a particle? They're going to be talking about particles. When are particles? Particle is any matter, anything. It could be a person, could be a thing, it doesn't matter. A particle is just a thing, okay? So a particle is at rest when velocity is 0. When velocity is 0, particle is at rest, okay? A particle changes signs, or sorry, changes direction. So we talked about direction, right? Velocity can have a positive direction or a negative direction. That's what, when it changes direction, when it changes the way, when it changes direction, that's when it changes signs, okay? They're gonna ask you questions about when is velocity increasing and when is velocity decreasing. Well, velocity is increasing when acceleration is positive. Velocity is decreasing when acceleration is negative. Okay? So when I'm in my car and I'm going 50 miles an hour and I don't change, it says 50, 50, keeps saying 50, doesn't change from 50, right? Your speed is 50, but what's your acceleration? 0, right? You're not accelerating. If I'm picking up speed, right? When you're getting on a highway, when you're getting on 99 or 41 or 180 or whatever highway you're getting on, when you first get onto the highway, you have to pick up speed to catch up with the rest of the traffic on the highway. Then your acceleration hits. That's when your acceleration increases, right? Or the opposite, when you're getting off a highway. So when you're getting off a highway, you got to slow down, right? That's when your acceleration becomes negative. You're slowing down, okay? So that's acceleration. How fast are you picking up velocity? How fast are you slowing down? How fast is your velocity decreasing? Okay? Speed is increasing when acceleration and velocity have the same sign. So speed is increasing when acceleration and velocity have the same exact sign. Okay? Speed is decreasing when acceleration and velocity have opposite signs. They have the opposite sign. Okay? And then the last part is the average acceleration of an object is the total change in velocity divided by the total change in time. It can be thought of as the slope of the line connecting 2 points of the velocity. Okay? The table kind of says exactly what some of the notes said. Okay? It tells you when things are happening. When are you speeding up? When are you constant? When are you accelerating? When are you stopped? When are you slowing down? Okay, so you're going to use that table a lot. And then down here, there's another table because they're going to say move right. When does a particle move right? You're like, right, what does that mean? Right is positive direction. Right means positive direction. When is a particle moving in a positive direction or a negative direction? So negative direction, that's when it moves left. When is it positive? When it moves right. Okay, so if you've had, we used to, back before COVID, we used to have a physics class. A lot of students love taking physics because you do things, you build stuff and build rockets and everything, but we haven't had a physics lesson in a while. So if you have a physics, if you kind of know about physics, a lot of this stuff, you're like, oh, okay, I get it. But you know, we haven't had that in a while. So a lot of this stuff might be new to you. Okay. But it's all related, right? Right here, it's all related, right? These little tick marks, they're just derivatives, right? So a good physicist, a good physicist has a good background has to have a great background in calculus, okay, to be a physicist. Physicist, you guys know physicists, the smartest guys on our planet are physicists. Stephen Hawking is a physicist, right? These guys are the smartest guys. Well, they're doctors of physics. What do they deal with? They deal with calculus all the time. Okay, so that's what physicists do. Okay, so we're looking at one of the things. We're looking at one of the things they do: position, velocity, acceleration. Okay, this right here, this first page is going to be everything to you. It's going to be everything to you because they're going to ask you questions and the answer is going to be right on this page. So if you're stuck, always, if you're doing a position, velocity, or acceleration problem, not just today, not just tomorrow, always go back to this page because this page will have the answers. I'm telling you right now, because everything's in there. There's so much information there. Okay? Okay, so let's look at the first one. Example number 1. Okay, so a particle moves along the x-axis, side to side, right? Particle moves. So that the time, thanks. So that time equals, so t, you see a lot of t's, right? If you look on the board, you see a lot of t's. That just means time. Okay, time. Time is always going to be the independent variable. because time does what it wants. Independent variable, x-axis. Time does what it wants. We can't stop time. Okay, so time is always the independent variable. So a particle moves along the x-axis so that time is greater than or equal to 0. So that just means time can be positive. Time can't be negative. Can't go back in time. So time's always going to be positive. Okay, its position is given by the equation x of t. Determine the acceleration of the particle at time equals 7. Okay, so they give us x of t. That's position. They give us the equation for position. But I don't want position. I want acceleration. So what do I have to do first? There you go. Take the second derivative, right? I need to take the second derivative of that guy. That's what I'm going to do first. Okay? I'm going to take the second derivative of x of t. So you can call it v of t, you can call it x prime. It doesn't really matter because it's all the same. Okay? So the first derivative is going to be 3t squared minus 22t minus 16. That's the first derivative. Okay, now we got to find the second derivative. Second derivative of t, or sorry, x of t, which is acceleration. Acceleration is 6t minus 22. That's the function. That's the acceleration function. Okay, so we got that. So how are we going to answer the question? What do we do now? Plug in 7. A of 7 equals 6 times 7 minus 22. 42 minus 22 equals 20. They don't give us units. They don't mention anything about units, so we don't have to mention units either. Sometimes they will, sometimes they won't. Okay, so we don't know acceleration. I don't know how they're measuring acceleration. Okay, but most of the time, if they do ask you to label, so see how can I put this? So position is always in meters, miles, feet, right? It's a distance. Position is a distance. Velocity is distance over time, miles per hour, feet per second, right? Acceleration is always distance over time squared, okay? So miles per second squared, feet per minute squared, okay? That's how you label them, okay? Position is always, I'm gonna say it one more time. Position is always distance, feet, meters, inches, centimeters, whatever the distance is, however you can measure distance. Velocity is distance over time, miles per hour, feet per second, whatever you want to say. Acceleration is distance. Acceleration, if they ask you, this is only if they ask you to label, because sometimes they will have you label, is distance over time squared. Over time squared. So whatever the distance is over whatever measurement of time squared. Miles per second squared. Feet per minute squared. Okay, so if they ask you to label, that's how you label it. Okay, all right. Okay, this one they didn't, so we don't have to, but they will in the future. Okay, so that's important to know. All right, so example number 2. Example number 2. A particle moves along the x-axis so that time is positive, starts at 0 and increases. Its position is given by x of t. Determine all values of t when the particle is at rest. See a puzzling look in some of your faces. Anytime you do this, what do? What did I tell you to do? Anytime you do this, when you're talking about position, velocity, or acceleration, or a particle, what do? No, I'm just talking about anytime. I'm talking about in general, not for this problem, in general. If you're talking about a problem that's position, velocity, acceleration, it talks about a particle, it talks about time, I don't know what to do. I'm confused. What do? Go right to this page right here. Right to this page right here. The answer is on there. The answer is on there. Okay? So go look at this page and tell me, when is a particle at rest? So when does it say particle at rest? So yeah, so the very, very bottom one, right? The last table that I give you, right there. Object stopped. That means it's at rest. Something that's at rest stopped. So that's what we're looking for. We want to know when v of t equals 0. Okay, that's what we want. That's our answer. Okay, so let's go back to the question. See how I make those little notes to myself? I know this stuff, right? But if I didn't know this stuff, it helps. Because in your notes, if you're just doing the problem, that's not going to help you later, right? How did I know how to solve this problem when v of t equals 0? Okay, you got to be good note takers. That's what good note takers do. Okay, so later you can't think of today. You got to think of 2 weeks from now, a week from now when you're studying for the test. How did I do this one? Okay, so I need v of t. So let me find v of t. 3t squared plus 12t minus 36. I got to set it equal to 0. Okay, it's quadratic factor. GCF. However methods you factor, whatever method you use to factor, you're trying to find the two numbers that multiply to be negative 12 and add to be 4. Positive 6 and negative 2. Whatever methods you use for factoring, the X and the box or the X, however you were taught in Math 2 and Math 3, go for it. Okay? Okay, so we factor, still equal to 0. I haven't been writing it, but I should have. So we got to set everything equal to 0. T plus 6 equals 0. T minus 2 equals 0. Solve for t. Okay. T equals, v of t is 0 when t is negative 6 and t is positive 2. More than likely, you'll see this on a multiple choice question. And I'll tell you right now, these will be the choices. Negative 6, comma 2. Negative 6. Positive 2. No solution. And E will be something else. Which one would be right? C is correct, yeah. Why is C correct and not A? I did it right. T has to be positive. T is always positive. So it's not that I did it wrong. I didn't do it wrong. I didn't do the problem wrong, but sometimes in math we get answers that aren't common sense. They don't make sense, right? This is theoretical. In real life, time can't be negative. Okay, so just be careful with that. Anytime you're dealing with time, it has to be positive. Okay. Okay, here we go. Number 2. Or sorry, number 3. So particle moves along the x-axis. That's how you'll know right here. It should sound like repetition, but that part I just highlighted, it'll always start with some variation of that. If it starts with some variation of that, you know you're dealing with a position, velocity, acceleration problem. All right, you'll know this is what you're dealing with. You'll always start with some variation of a particle moves along the x-axis, so that time is positive. It'll start with something like that. That's the giveaway. Okay. The rest of it will be different, but that part will always be, there's something very similar about that. Not exactly word for word, but essentially the same. Its position is given by x of t. Determine if the particle is moving to the right or to the left at 5. To the right or to the left. So I understand how to use the position. I did that before. This part, what? To the right or to the left? What the heck is it talking about? What do I do? Don't tell me the answer. Tell me, what do I do? Good. Like some of you are doing, right? Good. And what does it tell us to do? When does a particle move right or left? When? There you go. When velocity is either positive or negative. If velocity is positive, it's moving to the right. When velocity is negative, it's moving to the left. So that's what we have to figure out. We have to figure out when velocity is positive and when velocity is negative. What is that? What are we doing? What is it called? What is this process called? When we want to find out if the derivative is positive or negative at a number. It's gonna be on the test. It's one of the first things we did this chapter. Hmm? What is it called? What is that called? First derivative test. That's all we're doing. We're doing the first derivative test and we're checking at 5. Okay? So we're finding the derivative v of t. So we get negative 2t minus 8. I don't have to solve it because I don't necessarily want to know where it stops. I don't have to set it equal to 0 because I don't have to. I just have to figure out where is v of t positive and where is v of t negative. Not even that. I just have to figure out at t equals 5. So what do I do next? Plug in 5. Good. That's the next step. Negative 10 minus 8, I get negative 18. Is negative 18 my answer? No. What is my answer? Because, there you go. That's it. Particle is moving to the left. And then my justification is because velocity is negative at t equals 5. It's negative 18. Negative 18 is a negative number. So I'm using different terminology: particles, velocity, acceleration, position, but it's the same stuff we've been doing. First derivative test. Right? It's the same stuff we've been doing. We've been doing for a few weeks. Okay. All right. Okay, so let's look at the next one. Number 4. So again, we get the same preamble. A particle moves along the x-axis so that time is positive. So we know what we're dealing with, okay? Position, they've given us position again. Determine all intervals when the speed of the particle is increasing. Speed is increasing. So when does that mean? So go find that. When does speed increasing? When what? Yeah, Joshua? A of t and v of t have the same sign. When a of t and v of t have the same sign. Yeah, it's written on the table, and it's also written in our notes, right? It's right there. Speed. Let's see, what's the wording they use? Speed is increasing, right? Speed is increasing when a of t and v of t have the same sign. And it's also here too, right? Speeding up, a of t is positive, v of t is positive. Speeding up, a of t is negative, v of t is negative, okay? So it's on the table, and it's also there. It's different spots. Some people like to read the notes. Sometimes that makes more sense to them. Sometimes tables make more sense to you. So I just put everything on there, okay? So we got to figure out where v of t and a of t have the same sign. We've done this problem before.
I'm assuming we have to do the first derivative and second derivative test on this one.
So you've done this problem before, but it wasn't called speed and increasing. You did it on the last quiz we had. The quiz said when is f increasing and concave down, or decreasing and concave up, or increasing and concave up. That was the way they worded it then. It's the same thing. It's the same thing. Okay? So what did we do then? What did we do on that quiz? There you go. So we did the first derivative test and the second derivative test. That's what we're going to do. So v of t is 4t to the third minus 36t squared. Okay, that's the first derivative. Now I'm going to do the first derivative test. Set it equal to 0 and solve. 4t squared is the GCF. That leaves t minus 9. So set them both equal to 0. I get t equals 0 and t equals 9. Okay. So to do the first derivative test, I need a number line. Okay. Now I have to plug in numbers that are bigger than, or sorry, in between 0 and 9. In between 0 and 9. So 1. You plug in 1 to the first derivative. You can plug in anything between 0 and 9, but I'm just going to plug in the easiest thing I can think of. Let's see. 4 minus 36 is a negative number, negative 32. So that means everywhere between 0 and 9 is going to be a negative velocity. Above 9, 10. 4 times 10 cubed minus 36 times 10 squared. 10 cubed is 1,000, so 4,000. Minus 10 squared is 100 times 36 is 3,600. I get a positive 400. Do I need to check less than 0?
Yes.
You can. There's nothing wrong with it, but why is it not necessary? Why is checking over here not necessary for this problem?
I assume when you do the one,
Go ahead. Go keep going.
when you do the -1.
You can. It's nothing wrong with it. There's nothing wrong with it. You can absolutely do it. But why is it not necessary? Time can't be negative. We can't have a negative time, right? We can't have negative time on this problem. So we don't have to check it. There's nothing wrong with it. You can check it. It's nothing wrong with it, but it's just not applicable. It's not going to help us in our problem. Okay. Okay, so now we're going to do the same thing for the second derivative. So I need to find a of t now. So I find the second derivative. 12t squared minus 72t. Set that equal to 0. Uh, 12t GCF, so we get t minus 6. So I get t is 0. And I get t is 6. Okay. So now second derivative test. So I get 0 and I got 6. Okay. So I'm going to check 1 again. So we get 12 times 1 squared minus 72 times 1. So we get 12 minus 72 equals negative 60. So negative between 0 and 6. Above 6. We'll use 10 since 10's a nice. You don't have to use 10. You can use 7, 8, 9. But I'll just use 10 since 10's a nice round number. We get 1200 minus 720, which is positive 480. Again, you don't have to check less than 0. You can't. It's not wrong to do it, but it's just not necessary because time can never be negative. Okay. So now I'm going to pull back, and I'm going to look at both of my number lines, and I'm looking for what? What am I looking for? Where they have what? The same sign overlapping on each other, right? The same sign overlapping on each other. Well, from 0 to 6 on the second derivative, I have negative. So if I put that on top of the top first derivative, that's still negative, 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 right? So from 0 to 6 is one area. And then from 6 on, from 6 to 9, I have a positive down here and a negative up here, right? So that's different. But then after 9, what happens? Okay, it's all positive and all positive. So also 6, 9 on. They both have the same sign. So those are going to be my intervals of increase, or sorry, of increasing, of speed increasing. So I say speed is increasing from 0 to 6 or 6 to 9. Or wait, not 6 to 9. 9 to positive infinity. Justification, because. What's our justification for the reasons why these are our answers? There we go. Because V of t and A of t have the same sign. Doesn't matter if it's negative and negative or positive and positive. We just have to have them have the same sign. Okay, so this is the reason why I include, because every time we get to this, it's like, well, what does this have to do with what we've been doing? Everything. This is everything we've been doing. It's just they're using position, velocity, acceleration, right? So people say, when do we use calculus in real life? When is calculus? Calculus is all over science, all over science. Anytime you want to go into science at all, any type of science, you have to have a calculus background. You have to have a calculus background. Engineering, obviously, and math, obviously, but because there's a lot of calculus involved in all of this stuff. Okay. All right. So now we move to the graphs. It's the same questions I'm asking, but now I'm changing the thing I'm giving you. I'm changing the thing I'm giving you. I don't give you an equation. I don't give you a function. I give you a picture of the function or the picture of its derivative. Okay? So it's the same thing we've been doing. The same thing we've been doing. Okay? So let's kind of go read the problem. A particle moves along the x-axis so that its velocity at time is from 0 to 18. Okay, so from 0 to 18. Okay, is given by v of t, whose graph is shown in the figure below. The inflection points, we've heard that before many times, are marked with green circles. So they're not green on yours, but they're the dots on there. So you can see the dots on there. Those are inflection points. Okay. So let me highlight them, inflection points. Those are inflection points, okay? Find all of the intervals when the speed of the particle is decreasing. Okay. When is speed decreasing?
When the A of t and V of t have opposite signs.
Okay, so A of t and V of t have opposite or different signs, right? Different signs. Okay. One is positive, one is negative, or vice versa. Okay. What graph are we looking at? Velocity graph, right? And isn't velocity graph the derivative, right? So this is kind of like what we've been doing before, right? Where we were looking at the velocity, we were looking at the last lesson we did right here. Let me pull this up. All right, we were looking at this graph here. And that was the first derivative graph. It's the same question, just different terminology. Okay, so this is the derivative graph. It's the velocity graph. It says right there and right there. Okay, t is always time. The x-axis will always be t, time. Okay, so now we have to figure out where A of t and V of t have different signs. Well, first of all, let's figure out what signs V of t has. V of t. How do I figure out when V of t is positive? How do I figure out when V of t is positive?
When it is above the x-axis.
There you go. Yeah, when it's above the x-axis on the graph. Okay, so when it's above the x-axis, there. When it's below the x-axis, okay. So positive looks like from 0 to 1 is positive, V of t. So let me write this down. V of t is positive. Looks like 0 to 1 or 11 to 16. Okay. And it looks like V of t is negative from 1 to 11 and 16 to 18. Okay, done. Now we got to find out when acceleration is positive and acceleration is negative. So how do I know, looking at this graph here, when is acceleration going to be positive? When it's going uphill, when it's increasing, right? We're looking at the derivatives. We're looking at the derivatives. Okay? So increasing. Looks like increasing here to here, and then everywhere else it looks like it's decreasing. Right? We're just using our guidelines. We're just using those guidelines that we used the other day on ours. That's all we're doing. So A of t is positive, it looks like, in the purple area, 8 to 13. And then it looks like it's decreasing from 0 to 8, 13 to 18. Okay. We're done with the graph. Don't need the graph anymore. Okay. So now we just got to figure out, when do they have different signs? When are they going to, we're going to kind of compare them, right? So let me write this down. Speed of particle is decreasing. Speed of particle is decreasing from, okay, so now let's look at where it's decreasing, where they have different signs, right? Well, it's positive here, negative here. Is there anywhere they overlap from here to here? Is there any overlap there? 0 to 1. Where else? And 13 to 16. Okay. Now, let's do the opposite. Is there any overlap over here? 8 to 11. 8 to 11. Because V of t and A of t have different or opposite signs. Done. Okay. All right. Okay, so I want you to do number 6 now. Do number 6 on your own. We'll go over it in 3-5 minutes, something like that. Okay. All right, so last problem we do. It'll be the last problem we do, and then we'll finish the rest on Monday. So speed is increasing. We got to figure out where speed is increasing. Well, according to my notes, it says that's when acceleration and velocity have the same sign. Okay. All right, so velocity. So they gave me, again, they're not always going to give you the same graph. In fact, on number 7, if you look, they change the graph in which they give you. They give you x of t. Okay, so you always got to check to see which graph they give you. But this one, they gave you the same graph, v of t. Okay. So we got to figure out where v of t is positive. That's above the x-axis. Negative is right here. Okay. So from 1 to 9, and from 9 to 17. Negative is from 0 to 1, or 17 to 18. Okay. Acceleration. That's the derivative of this, so that's slopes. So acceleration is positive when it's increasing. So increasing here, everywhere else it's decreasing. Okay. 0 to 4. Or 9 to 12. And then everywhere else, what is that? 4 to 9, 12 to 18. Okay, so let me write this down here. Speed is increasing from same sign, right? So let's look. Same sign. Where's the overlap? 1 to 4. Yeah, I think 1 to 4 is it. No, 1 to 4 and then 9 to 12, right? 1 to 4, 9 to 12. Okay. Let's look over here now. Here and here. 17 to 18. That's it, huh? Yeah, 17 to 18. Because A of t and V of t have the same sign. Same signs. Done. Okay. Okay, so we'll finish the rest on Monday. We just got 2 more problems. They're just changing the given information. That's all they're doing, the difference there. It's the same thing, but just changing the given information